Topic 1-9. Essential question. How can you write expressions to describe patterns? Presented by your lovely teacher, Miss Villaseñor. Make sure you write your notes down and get everything ready. And if you have any questions, you can work with a partner or see your teacher for coaching. Okay, so this example is from your book, and what we need to focus on is finding the pattern to be able to make an expression, okay? So if we look here at the input and output, you see that 84 and then it's 42. So if the number becomes less, your operation's either going to be division or it's going to be subtracting, okay, if the number goes less. If it was to go higher from the input to the output, then it would be adding or multiplication. So if we're going to write an expression, you know it's either going to be division or subtraction, okay? So according to the problem here, it says that Devin saves a part of everything he earns. So the table at the right shows Devin's savings pattern. So the input shows how much he has earned. So that means how much he gets paid. And then the output shows how much money he has saved. Then we write an expression to describe the pattern. So if he made $84, he saves, his savings is $42. Okay. So if we look at the table here, we see that it goes from 84 to 42. And sometimes we have to look at a couple numbers to see if we see a pattern here, right? So if then we went from, if he made $66 and he has saved $33 of it, then 50 to 25, I can see that it went half. It's split into half, right? So if you think back, oh wait, 50, half of 50 is 25, and half of 66, 33, and yeah, 84 divided by 2 is 42. So we know that our pattern is going to be, we're going to divide by 2, okay? So we know that every time, let's start with 50, that might be easier. So we know that if we divide 50 into half, it gives us $25. So I think we found our expression here. Okay, so our expression is that every money he makes, he divides it into half. Okay, so we see that there. Okay, so what is the relationship is that the input is divided by 2 to be able to get the output. Okay, so on here, if we use the patterns to find the missing values, if he made $22, right? So out of 22, and then if we divide that by half, would equal 22 divided by 2 gives us $11 that he saves, okay? So the expression is 1/2, and if we make x the input, 1/2 x will give you the output, the savings amount, okay? So for $30 here, 30 divided by half would give you $15, okay? So that means 30 divided by 2. Okay, every time we say half, it means divided by 2. Okay, let's try the guided practice and use the input and the output table to answer questions 1 and 2. So we have to use this. So the question for number 1 is, if the input number is 8, what is the output number? Okay, so if the input is 8, oh, well, we have that missing, right? So 8, what is the output? So we'll put X for output. So if we look at, we've got to try to find a pattern. So we know that from 0, then we go to output 3, it's going up, right? From 1, then it goes into 4. Okay, from 2, it goes into 5. So remember what we said, it's your operation is going to be either adding or we are going to be multiplying. Okay, so if we look back at the pattern here, let's see, if we say 0 plus, let's try the first one here. So we have our x. No, never mind. Let's not say x. Let's say we have input. This is your input. And we could rewrite it this way. Even though they're going sideways, it might be easier to see it that way. So if our input 0, all I'm doing is turning this over here. 0 to a 3. Can I multiply? Because remember, it's either going to be adding or multiplying. Can I multiply anything from 0 to get a 3? No. 0 times anything, it's always going to be a 0. So we know it's not going to be multiplying. It's going to be adding. So the operation is going to be adding. 0 plus what will give me 3? Oh, well, we have to add 3. So maybe the pattern is we have to add 3 to the input, which we'll call x. Okay, so if we put 0 here, 0 plus 3, does it equal 3? Yes. Okay, so let's test this out for the next one. So if we say, okay, then we have now the input is 1 and this is 4. So if we say this is x, normally we call that y. So this is technically your input. This side's your output. So we remember the pattern we thought 0 for 3 is adding 3. So let's test this out. If I say 1 plus 3, does it give me 4? Yes, that checks. What if we put a, like how they have it here, a 2 and a 5? Does 2 plus 3 equals 5? Yes. Okay, so what about 3 plus 3? Does that equal 6? Yes. Okay. And 4, I won't write it down, but 4 plus 3, yes, it gives you 7. So now, they're saying if the input's 8, what are we going to do to that 8? We're going to add 3. So, to answer number 1, if the input number is 8, what is the output going to be? 8 plus 3 will give us 11. So your output is 11. Now we have to write number 2 says, write an algebraic expression that describes this pattern. So we can call x for input, remember? So our pattern is going to be, let me erase all this so it's not all over the place. So the expression is going to be x plus 3, okay? Because all we did was add 3 to the input to be able to get the output, okay? So your expression is, no, we don't need an equal sign, just x plus 3 for number 2. Now in number 3 it says, suppose that Devin earned $36 mowing lawns. What input and output entries would you add to this table? That's from the one that we did earlier. So remember, we would divide, remember savings for number 3. If he saved, it was half of what he saved. So if he made $36 and he is saving half of it, how much savings is he, what is the input and output to add to this table? So remember the input is how much he made, which was 36. What's the output going to be? What is the savings account? So then we do 36 divided by 2 because that's half. 2 times 1, bring down to 6. 2 times 8, minus 16, 0. So the savings account would be 18. So the input would be 36, output would be 18. Okay. Now, number 4. Is it reasonable for an output to be greater than the input in the table above? Could it be that they're asking, could the input ever be bigger than the output for the example about how he earned money, which was the input, and he's saving? How much does he save from that? No, you can't have the value greater than that because he's saving money from that. It's not like he's making more money. Okay, so number 4, you would say no, because he's making this money and the other one's being saved. Okay, the last section, number 5, says what algebraic expression division also describes the output pattern for the table above. So